Welcome to installment 20 of writing a 6502 assembler in 6502 assembly language. In the last episode or last installment, I wrote the code to handle the temporary or numeric labels. There will be one other tiny thing to do with regard to that, but that will come in the future, although soon. For now, let's go back and look at the actual code which tries to read a statement. And I think this was from 2 or 3 episodes ago. I wrote this code. The purpose of it is that the main loop of the assembler simply reads one statement after another from the source file until it gets to the end of file, and then it's done. If it was the first pass, what we'll do is close the file, go back, reopen the file, and go through it with a second pass, just reading it exactly the same way I read it the first time. But the difference is then the second pass, all of the symbols will have been defined. Well, if they haven't, it's an error. But basically, this subroutine here is the heart of the assembler. And so what this subroutine does is it's called repeatedly by the main routine, and all it does is look for a possibly labeled statement. It's going to need a pointer, so the first thing it does is reserve space in 0 page, the 50 and 51 spaces, hexadecimal. What it does is it takes the current value there, pushes it on the stack, so that the spaces are now available for to use. It calls the scan subroutine, which returns a token. It says, okay, did I get a label? If I get a label, then go to lab statement 0. If I got a numeric label, go to lab statement 1. If I got an end of statement, which is actually just a new line, then go to lab statement 2. If I get a comma, which is another way to end a statement, go to lab statement 2. If I get EOF, go to lab statement 3. Otherwise, I didn't get any label, I didn't get end of line, I didn't get end of statement, I didn't get end of file. So we unscanned the token that we got and jump to the statement subroutine because what we got is not a label. And that means it's part of a statement. So we unscan it to put it back and then call statement to actually parse the statement. If we got an end of file, we come here where we set carry to, we set the carry bit, meaning end of file, and we then branch to lab statement 6, which is the return. If we got end of statement or end of line, we go to lab statement 2, which does the same thing, only it clears the carry flag. And then we go into lab statement 6, which is return from subroutine. All it does is it retrieves the values of 0 page 50 and 51 that we put in the stack, puts them back into those 0 page locations, and returns. All right, lab statement 1 is where we got a numerical label. And remember, when we get a numerical label, the address of the 2-byte value of that label is put into tokefile. So we load that into X and Y. We store it into the pointer we have. And then we have this little loop which copies the value out of dot, which is the location counter. It basically tells us how many bytes we have already assembled in the file, all the previous statements to this one, how many bytes of object code do they generate. That's what's in this variable dot, and that gets put into the value of this numeric label. All right, we take it from dot and put it into the value of the numeric label. We have a pointer to the numeric label in these 2 locations. All right, it's a loop here, but this loop copies only 2 bytes and then it's done. And then after we're done with that, we branch up to lab statement 9, which is the top of this routine. And the reason we do that is because we can have multiple labels in a line. We get a label, we could have another label, and so on until we finally have a statement of some sort. Okay, and we come to lab statement 0 if we got not a numeric label, but a regular label, a label that's named. And it's quite similar. In this code, the address of the symbol table entry of the label is put into Tocqueville. So in the same way, we get that address out, put it into our 0-page pointer. But this is a 16-byte long symbol table entry, and the value of the label is in bytes 14 and 15, offset from the beginning. So we put a 14 on Y, and then we have to load dot minus 13 because we want to, we're going to add 14 to it here. All right. And then we store that. So it's the same thing. We're just copying the value of dot into the symbol table entry. It's just different from this one up here in the sense that the only thing in this entry for the numeric label is just the value. Down here we have the value plus other stuff, so we have to make an offset. And I think this is actually a mistake because the value of the named symbol is in bytes that are offset 14 and 15 from the pointer, and we're actually copying them in backwards. That is, we're copying the 15 byte offset 15 first and then 14. So it looks like this should be 15. Why did I put a 14 there? The first 12 bytes, that's offset 0 to 11, is the name of the symbol. Offset 12. Oh, I'm sorry. That's my mistake. The problem is that the entries are not 16 bytes long. They are 15 bytes long. That's right. 15 bytes long. So that was a little, brain problem there. I forgot that the symbol table entries were 15 bytes long, not 16 bytes long. So 14 is the correct offset for the value. So load the dot, put it in there. Again, this loop only executes twice. It only loops twice. And when we're done with it, Y is 12, which is the offset of the type of the symbol. And named symbols have types. In this case, for the moment, all we care about is to put something there which is not 0, as you see with this comment here. And the reason is because 0 means undefined symbol. And then the other types will be other things, but for the moment we just care about that it's not 0. Later on we'll go back and do all the different types, but that will actually wait until after we're actually using this assembler to assemble itself. For now, everything's going to be treated as absolute, and we'll just put a 1 in there to say it's not undefined. All right, and we branch back up to the top to see if there's another statement to get up here. Good. So now we are at the point where we have to start working on the statement subroutine. And here it is. Okay. What we're going to do is we have to JSR scan again. Now, what can we know about this? Well, we know that we did a scan here, and we're going to find a label, a numeric label, or end of statement, or comma. So if we find any of these things, then we're not going to go to statement here. We're not going to call a statement subroutine. So for me in particular, that means I know that it's not, when we call the statement subroutine, it's not going to be end of file. It's not going to be a new line, which is this, or end of, or a comma, which is also a way of saying end of statement. So that means I know I have something real here, maybe possibly something which is an error or erroneous input, but it's at least something that's not end of file, end of line. So let's start going through the possibilities of what it could be. It could be a string, and that's probably the easiest thing to do at the moment. What's coming back in the A register could be a string. And I believe, I could be wrong, that is, I have defined it to be tstir. All right, and basically in the first pass, we're not going to generate any code, so we don't really care what the bytes of the string are. What we care about is the length of the string. And of course, it's quite easy to find the length of the string by just counting the bytes until you get to the null termination at the end. But why would we do that when we already know the length of the string when the string is built? Unfortunately, I don't think I actually included that information somewhere. At least I don't know if I did or not, so we'll have to go look. So this will be in the file AS1. Oh, hang just a minute. Let's go to AS0 because that's where these. Yeah, actually, it's all going to be in AS0 anyway, not AS1. That was a mistake. Yeah, I have tstir. There we go. All right, so I know that if I got a string, it's tstir. All right, well, here's all the get stir code. And let's just see, where's the place where here's the place where I have the string because I'm loading tstir and returning. It's being stored in textbuff, which, if you remember, is actually hexadecimal 200. Okay, and X is counting the number of bytes in it. Okay, here's where we've finished getting the string. We're going to load a 0. We're getting the X value back. We're storing it in there and loading tstir. So what we ought to do here is store this value of X in tokefile, in the tokefile variable. All right, so let's do that. Okay, that's putting the 0 there in the end. So we'll first txa and then store that in tokefile. Okay, X is the length of the string, and then load tstir. So when we get a string, I'm going to just type this in here and then delete it. It's just to explain. When we get a string, then in location hexadecimal 200, we have the text of the string. That is all the characters followed by a null byte at the end to terminate. In the variable tokefile, we have the length of the string. And in the A register, we have the token tstir, all right, which tells us, oh, what we found was the string. Okay, so now we can just load what's in tokefile to find the length of the string. All right, so let's save that and go back to where we were. Okay, so if it is a string, so first off, if it's not a string, then we'll check and see if it's something else, right? But if it is a string, then what we have to do here is we just take that length of the string and we add that to the value of the variable dot, right? So for example, if in our source file we had something like this, hello, okay, or even like this to put a null byte in it, then what's going to happen is that this will be then 1, 2, 3, 4, 5, 6 bytes long, and in tokefile we will have a 6, and we can take that and add it to dot because we're telling it that means that we're going to output 6 bytes here into the object code. So all we have to do is now, right, if it's, I think I will just have to, I think I'll go ahead and have to clear, whoa, what am I doing? What's going on here? All right, clear carry, load tokefile, add that to dot, store into dot. I'm going to change this to 1, so it's 0A, well, or 0. Okay, inc dot plus 1. So this is just handling a carry from this addition here. Okay, and at this point we're basically finished. We found a string statement, which is one of the type of statements that we can have. I'm just thinking now, do we need to try to look for an end of statement mark of some sort, that is to say a new line or something else? Let's go back and look up here. So if we here get a statement, so actually I just thought of something. So this is looking for a one or more, or zero or more labels followed by a statement. So if we get here end of statement, that basically means that there's a label, but then there's nothing else. It's like label, end of line. And that's fine. There's nothing wrong with that. But do we need to allow label, comma? I don't think we need to allow that. If you're going to have just a line that has only a label on it, we don't need to allow a person to say label, comma. I don't really see the usefulness of that. In other words, it's just fine to say something like label foo, label bar, label baz, and then have some sort of code here, right? Like, that's fine. That means that all of these labels will have the same value. They'll all be the address of this instruction here. But is it really useful to say something like this? Label foo, comma, label bar, comma, label baz, LDA 0. I think this is completely useless, and the reason why is because we don't have to do this. This is already allowed. Like this. Or, I mean, even I don't think there has to be white space there. Okay, that's ugly. Don't do that. But, I mean, this is already allowed, right? Because when we get a label, after we get our label here, where is it? Label 0, right? We just branch back up here to the top, which allows us to get another label. So we don't need to allow commas here. So I think instead, I'll take that out. So we're not going to allow kind of empty statements that are separated only by commas, at least in a certain sense. We're not going to allow it here. But down here, after we've gotten a statement here, like we've gotten a string statement here, then what we probably ought to do is, let me just jump to statement 9. And what I'll do here now is go ahead and scan. So we've gotten a statement, we're going to scan. And if we get a end of statement that is like a new line. Oh, and I want to point out one just a minute. This jumps to statement. So once it's finished getting labels, it goes to statement, and everything, I mean, statement, when statement returns, it'll return back to the main routine. It won't return here. Okay? And I think that's what I want to have happen. So at the end of getting a statement, I should look for an end of statement. So, okay, compare end of statement. If we get it, then we'll go to 9a. That's going to mean, okay, good. We'll compare it to a comma. If we get that, we'll say, okay, good, we got an end of statement. If we get an EOF, then what we're going to do is we're going to put that back. Yeah, we're going to put that back. And then we will go to end of statement. So in other words, we're going to say, fine. Like at the end of a statement, if we get an end of statement, which is a new line, great, that looks wonderful. If we get a comma, great, that's wonderful. If we get an end of file, well, we'll put that back and then say, okay, but otherwise it's fine. It counts as end of statement. And anything else now is going to be an error. And the reason anything else is going to be an error is because we've parsed an entire statement and we just have leftover tokens on the line, and there's no reason for them to be there. All right, so what we have to do here is we have to let me just call ext error. And we just jump error. All right, and here's where we're going to, this is going to be our successful statement. And here we need to go ahead and put this in. So ext error, we're going to put our message here. And what can the message be? Unexpected token. Okay, well, maybe I'll change it later, but I'll leave it like that for now. Just unexpected token. Okay. And maybe just change this to unx, because I could see there being other cases where we have an unexpected token. Like we don't expect to get a token here because in this case, we're at the end of a statement and we just got a token, but right, it's not what we wanted. All right, I mean, I'm not sure this is a great error message, but for now, it'll be okay. All right, and here's the place where we go when we successfully got a statement, which is basically just RTS. I mean, here, get rid of that. Okay, good. So now we have one way to get a statement, that is to get a string. Okay, another possible statement that we can have is an expression. Okay, and an expression, well, let me hang off on that for a moment. Actually, there's the next way that we can have a statement, the next thing I'm thinking of is we can have an assignment statement. That is to say, in this assembler, you can do something like this. Foo is, well, you can just do math if you want to, all right? 5 times 7 minus 3, shifted right 2. I mean, you can just do something like this. Shifted left 2. So we do some calculation, assign the result of that calculation to this symbol foo. In most assemblers for the 6502, this is done with an EQU statement. So you have something like foo, EQU, and then you have your expression, which sometimes is very limited in what kind of arithmetic and logical operations you can use. In my assembler, there you will have a pretty wide range of things you can do, as long as the result fits in 16 bytes. And so we would notice this by seeing that we do I'm sorry, that's not right, JSR scan. And so we saw that it's not a string. So now we're going to see if it is a symbol, which is name, tname. If it's not, then go to statement 2. All right, and in statement 2, we'll see if it is a number. Okay. Is that good? Yeah, I think so. So if it is a number, then we'll go to statement, I'll just say 5 for now. And then we're going to look for tinref. Now I haven't done inref yet. What inref is a reference to a numerical label. So if you remember, the numerical labels look like this. 1, for example. If we want to refer to them, then we have to, if we want to refer to this label here, we can, for example, here say jump 1f. Okay, and what this means is jump to the label 1f. That means the one label which is forward from this one, so it's going to be this one here. And then here, if we want to refer to it in a backwards direction, we could say, for example, BEQ 1b. And this means refer to the label 1 in the backward direction, which is going to be here. Okay, so a tinref, and actually maybe I shouldn't call it tinref. Let's call it we need a forward, right? It's going to be one like this. And we need to take care of backward. Okay. So I'm just thinking maybe I want to check for these here instead. Okay, so compare T forward. And the reason for all this is because there's multiple kinds of statements that can start with a name. With a forward reference, we have to do something special. Okay, and then BNE statement 3. We have to see if it's a, I'll call that a backward reference. All right, and now we can see if it's just a number. Because the thing is that a number, if we get a number, it's always just an expression. If we see a token which is a number, then that means it's the start of an expression. Okay. So we're handling cases if we see a name, a label, a reference, a forward reference to a numerical label, a backward reference to a numerical label, or a number. And ultimately, all of these things are going to lead towards expressions. They can all be part of an expression, right? Because my expression could be something like 2 times bar plus 1f. This would be a valid expression. So if it is not a number, I'm just going to go to statement, I don't know, 7 or something like that for now. And this is going to here be, it's an expression. All right. And in fact, I'm going to have to, I think maybe I'll need a label here like this. It's an expression. So first off, let's look at the case of a name. If it's a name, then either it's part of an expression or it's part of an assignment statement. So what we actually have to do is we're probably going to need to remember what we're going to need to do is we have to scan again. All right, and we see, okay, if what we got is an equal sign, then it is an assignment statement. Okay, if it is not an equal sign, then we need to put back the equal sign. Okay, so if it's not an equal sign, we'll go to statement 1A, and here is handle assignment statement. And here we need to put back the equal sign. But now we have the little problem that we've lost the original name. So you kind of have to almost put back, well, we need to save this value of this name here. And I think the way we're going to do that is we'll just save it on the stack. All right, so if it's not a name, go down there. Otherwise, and the key thing we need here is we need the pointer to the symbol table, which is in the toke file variable. So let's push that, push that. Okay, so if it's a name, we're going to push the pointer to the symbol table entry. We're going to call scan again to see if it's an equal sign. That is, there's an assignment statement. If it's not an equal sign, we'll go down here and we have to unscan the equal sign. And now we need to retrieve the pointer to the symbol table entry, like that. All right. And in fact, let's just load tnam. So we've completely restored this token we had. We've restored the pointer to the symbol table entry. We've restored the fact that it's a name token, and we're going to go ahead and unscan that as well. And now we have the situation that it's a name, but it's not followed by an assignment operator. This thing here. So it's just it's part of an expression. And statement 5 is it's an expression. So jump, statement 5, go parse that expression. All right, and we'll come back to this in a minute. Now, if it is a forward reference, a reference to a numerical label in the forward direction, yeah, actually, I don't think we need to do anything really. We just need to put it back and jump to statement. The same with a backward reference. We need to put it back. Jump to statement 5 to get the expression. Okay, if it's a numerical statement, I mean a number, if it's not a number, we'll go down there. If it is, I see, this is nice. So actually we're going to have to unget the number as well. And so that means up here, we don't need this. And we don't need this. And we don't need this. So instead, actually what we need is here, if it's a forward reference, a reference to a numerical but temporary label in the forward direction. If it's not, we go there. Otherwise, jump to statement 5. But statement 5 is closed, so we can just say branch of equals statement 5, and then that goes away. All right. Branch of equals statement 5. All right, and that means we don't actually need these. Okay. So it's a string, we've handled that here, it's all done. Otherwise, if it's a name, if it's not a name, we go down here. If it is a name, we're going to save the pointer to the symbol table entry, look for an assignment operator. If it's not an assignment operator, we'll go down here. We're going to unscan unscan whatever. We're not unscanning the assignment operator. We're unscanning whatever it was that was not an assignment operator. Okay, and then we retrieve the pointer to the symbol table entry. We reload name as the token type and jump to statement 5. All right, if it was not a name, then we go down here, we say, is it a forward reference to a temporary label? If so, jump to statement 5. Is it a backward reference to temporary label? If so, jump to statement 5. Is it a number? If not, jump to statement 7. That's going to be down here somewhere. All right, and otherwise, here at statement 5, we're going to unscan whatever we got, which is a name, not followed by an assignment operator, or a forward reference to a temporary label, or a backward reference to a temporary label, or it's a number. All of those things come here, and it's an expression. And what we'll do here is we will just, I'll delete that, but we're just going to jump to basically parse expression. I just call it expr. Expr is going to be the subroutine that parses an expression. And after we're finished with that, we can jump to statement 9. So parse an expression, and then once we've parsed the expression, we're finished. And we'll come down here. Now we can take a look at this again. The assignment statement, okay. So it has pushed the pointer to the symbol table entry on the stack. We get an assignment operator. So handle assignment statement, the way we're going to do that is just go ahead and on the right-hand side of the assignment statement is an expression. So we will JSR expr to parse the expression. And now assuming that the expression parses, that there's no syntax error in the expression, we can take the value of that expression and store it in the symbol table entry for this thing here, right? So what we'll want to do, and I'm just looking here, do we need another 0-page location is my question. Jump statement. So when we jump to statement, we already have a symbol. We already have, the 0-page location has already been allocated, so we can use it. In fact, we have to use it. We have to restore it. Down here, we're going to have to restore that 0-page location. Okay. And we're also going to have to restore it in this case here. Okay, so this is the error situation. You know, maybe, yeah. Okay, what we should do it here. So the first thing we do is restore the 0-page location by pulling it off the stack. Then go ahead and scan to make sure that we get an end of statement as we expect. All right, and then this is again RTS. So whether that we're first, when we get this statement 9 means we've finished reading a statement, and now we'll go ahead and restore the 0 page location, and then we either get an error or we don't. Okay. So that means the 0 page location is available for us here. So there will be some sort of error indication from the expr subroutine, whether or not we parse the expression correctly, whether that, there was no syntax error, everything's good or not. For the moment, we'll just kind of assume that it is correct. And the value of this expression needs to be stored somewhere. It has to be a 2-byte numeric value. It can also have a type though, so we'll probably have some sort of extra variable for that, which could be expr val, expr type, something like that. So let's say we need to first off get the pointer to the symbol table, which is on the stack. Here, we put it right there, the pointer to the symbol table entry. And we'll store that in our 0 page location. We'll load y with 0 will be fine. And now we need to get the, no, not 0, we need to load with a 12. Because the type in the symbol table entry, the type byte has an offset of 12 from the beginning. So load expr type, store into the symbol table. All right, increment y. Expr val. And, we could do it in a loop. Should I not? If I do it in a loop, then I have to do like this. So I have to compare y to 15. Which is statement 3. Okay, store. Okay, so load expr type, store it in offset 12 in the symbol table entry, increment, compare y to 15. If it's 15, we've copied all 3 bytes. That is the type, 1 byte of type and 2 bytes of value. And branch of I equals statement 3. The big thing we need here is that if we do it this way, it is absolutely required that our expression variable, where am I going to put it? I'm not really sure it should go in this source file at all, but we'll just put it here for the moment. Okay, has to look like this. Okay, expr type has to be immediately before expr val, so if we copy all these 3 bytes to get copied correctly into the symbol table also has the 1 byte type followed by 2 byte value. Okay, so we're copying the value of this expression that we parsed into the symbol table as the value of this symbol here, which is exactly what an assignment does. So after we've copied that in there, we're done. And we can jump to statement 9. Okay, so unscan that stuff, expression, and jump to statement 9. Actually, when we get an expression, what we'll have to do is enter the value of that. That expression will be a 2-byte value, which has to put out an object code. But for right now, we're not putting anything into object code. Instead, we'd have to increment the value of dot, which is our location counter, which counts how many bytes we put into the object code. We have to increment that by 2 because an expression is 2 bytes. It's a 2-byte value, and we will put it out into the object code. So let's just clear carry, load 2, add token, not token, but add dot, store that back into dot. If carry is clear, skip, otherwise increment dot plus 1. Okay, and actually, I'll assume that statement 9 is going to be close enough, we can just skip down there. We still need this though, which makes me think, why not just do it this way? Okay. All right. So now at this label here, statement 7, we have the situation that we did not get a string. We did not get something, we did not get an assignment statement. We did not get something which looks like an expression. That is to say, a symbol not followed by an assignment operator, or a numeric label reference, or a number, or things like that. So what's going to be in this case right here is a pseudo op or an instruction. And we don't really want to look through all the possibilities, I think, right here. Well, this just gets kind of complicated because there are lots of different possible pseudo ops and lots of different possible instructions, and they all have to be handled in specific ways. So at this point right here, there's a lot of code to write, a lot of checking to do. But actually, I just don't want to really do that right at the moment. Instead, what I'm going to do for now is, if we're here, I think what I'm going to do, and this is just temporary, of course, I'm going to compare to an end of statement. If it is end of statement, I'll branch down to statement 9. I'll compare to a comma. If it is, I'll branch to statement 9. I'll compare to end of file. If it's if it's not an end of file, let's just go to statement 8 or just 7a. If it is an end of file, I'll unscan that end of file, and then jump to statement 9. And here is statement 7a. I'll just JSR scan jump statement 7. So the purpose of this code is just going to say, if it's none of the stuff up above, it's an instruction or a pseudo op, I'm just going to read tokens until I get the end of statement or end of file, right? And when I get those, I'll return. So this just basically will, any line that doesn't have the things that we're checking for specifically, it doesn't have a string, it doesn't have an assignment statement, it doesn't have an expression, all the tokens will be read until end of line or end of statement, and then this will return. So in other words, it will ignore everything else. That's the idea. Okay, so the thing that needs to be done next is to go back to the scanner and generate these T forward and T backward references. But I think I will do that in the next installment. So until then, goodbye for now.